So, question number 5. Right here, we are given a spring. Oh, all right. Okay. Question number 5. We're given a ball dangling on like a string, right? There's like a spring and like a ball dangling on it, and now the spring is being twirled around, and as you can see with a constant speed over here. Now, the distance from the spring is now 10.8. While before the spring was even moved, it was only 8.5 centimeters. The length. So the length when the sphere is moving is increasing. And the question 5a is asking about why the length of the spring extends. So the reason why it extends is because if we draw the forces that's happening between the spring and the ball, we'd have the tension of the spring, which is indicated by the red arrows. The net force or the net tension of the spring is going directly to the spring itself. The net force happens because there's the force happens on the y and the x axis. So yeah, and then after that there's the weight that goes down, marked by the green arrow, right there, marked by the green arrow. Now the reason why the spring is extended when you move it around is because the only force that are like the only force that's interacting with the weight is the vertical component of the tension, the vertical component of the tension from the spring. That's the only force that's interacting directly with the weight, with Fy, because the weight over here is only acting in Fy. It's not acting in Fx. It's not interacting with the net force. Is acting with the y-axis, or like the vertical component of the tension, and that tension, that the vertical tension, it's equals to the weight, because sigma Fy in here is basically 0, because it maintains the length. So sigma Fy is 0. Uh, 5b, the angle between the linear axis of the spring and the vertical is 27 degrees. Just 27 degrees, right? And then show that the radius of the circle is 4.9 centimeters. So how we can find the radius of the circle with just the angle? We can use the formula of, if I'm not wrong, it's the theta is equals to no, sorry, it's the distance is equals to theta times r. So we can find the radius of the spring by r is equals to, wait, hang on. Oh wait, actually, never mind. We find this by the length of the spring is basically acting as the hypotenuse in here. You see this is making like some sort of triangle, you know, and then we have the radius over here. Hang on, let me annotate. So this is the spring, right? This is the spring length, and then this is the spring radius. And then like we have this over here. Now this is kind of shaping like a triangle shape. If it's shaping a triangle shape, then we can use the trigonometry sin cos tan, since the radius is the opposite from the angle. We use sine theta is equals to opposite over adjacent. So which is basically this. Sine 27 is equals to the radius over the hypotenuse, which is the length of the spring. And after calculation, we get 4.9 centimeters, which is the radius. Show the tension in the spring, that the tension in the spring is 3.2. So we know the radius. We know the radius. Now we're finding the tension. So tension, like I said before. So tension. If we look at the forces over here, only tension that can interact with the weight is the y-axis tension. And as I said earlier, since the length is constant, that means it's not changing, not going up or down. That means sigma Fy is just 0. If sigma Fy is 0, that means the tension and the weight is the same. So with that being said, T cos 27 minus the weight, because this is 27 degrees. Hang on. This right here, 27 degrees. And we're trying to find this one, Ty. If this is 27 degrees, that means this is 27 degrees. And since Ty is adjacent with the angle, then we use the cos theta times cos theta times the tension, the original tension. And then we put that in, minus weight, T, that means T cos 27 would be equals to weight, and that means T is equals to weight over cos 27. The weight here we can find because I forgot to mention this. There is, we are given the mass over here, 0.29 kilograms. That's the sphere. So 0.29 kilograms times 9.8 as given right here. And then after calculation, a bit of rounding, we get 3.2 newtons. That's the tension of the spring. Now, the spring here obeys Hooke's law. Calculate the spring constant in Newton per centimeters of the spring. So, Hooke's law, basically delta T is equals to the constant of the spring times the difference of the spring length. Basically, when the spring extends and or maybe let's say the delta x when the spring is normal and when the spring is extending, basically we just calculate the length differences of the spring, and then we calculate the force difference, or the EPE, let's say. So we got the tension, and then we know the weight. We just do 3.189 minus 0.29 times 9.8. that is basically and then we get this 10.8 minus 8.5, which we get 2.3 times the constant is equals to 3.189 minus 0.29 times 9.8. And so constant is basically just 3.189 minus 0.29 times 9.8 divided by 22.3, which later you can get is 0.15. 5C. Use the information from B to determine the centripetal acceleration. Now, centripetal acceleration, the formula is v squared over r. So yeah, that's centripetal acceleration, and we use F is equals to ma, just that the acceleration is changed with centripetal acceleration, because the force here is the one that's keeping the ball in, like the tension goes, okay, wait, see the tension goes, hang on, so the tension goes this way, right? If we have sigma F is equals to m times AC, then that one goes the other way. This is the centripetal force that's keeping it intact as well, or like keeping the spring intact. Right. So with that being said, sigma fx is equals to mac. Sigma fx, there's only one force that's acting on the x-axis, which is the tension. So T sine 27 is equals to 0.29 times acceleration. So 3.189 sine 27 is equals to 0.29, and then after that we can find AC, which is 4.99 or 5 meters per second square. And then finally 5C2, calculate the period of the motion. So the period of the motion we can find from the angular acceleration. The angular, or like we can say like the W. The W is basically just 2 pi over the period. So that means we can find and we can also find the W from velocity, because velocity is W times the radius. So with that being said, AC is equals to v squared over r. V, the velocity, we can change to W times the radius. W times radius squared, meaning W squared r squared divided by r. So that means W squared times r, because one of the r cancels. So we just substitute the one that we have, which is the centripetal acceleration and the radius. And after a bit of calculation, we got the W, or the angular the W. Now the W, as I said before, 2 pi over t. 2 pi over t is equals to 10.09, and t is basically just 2 pi over 10.09 over here, and that equates to 0.62 seconds, right?
Oh wait, yes. I don't think we have enough time. So it's just one number.
Just one number.
Yeah, just one number.
Okay.
We'll go to the next.
All right.
Okay, so for this number, we are basically asked to determine the force exerted on different times based on the graph over here. So for letter A, at t equals to 0, it is over here. We know that generally the formula of force exerted is F equals to ma. You expand the ma, it'll be this. Because G is also affecting the object. So from this, the acceleration, we know that from the graph, the acceleration is the same as the gradient. And we know that the gradient over here until here is the same because they're a straight line. So you substitute the values, then you'll get this. And for point B, at t equals to 0.5 seconds, it is over here. Notice that A and B are has the same gradient, so the value of the F is the same. For letter C, at time 1.1 second, it's over here at the peak. At the peak, the acceleration is 0 because the person just hangs on top of there, so there's no movements. So for that, you replace this as 0. So the only acceleration that is acting on the object is gravitational force. Then you'll get this. For letter D, at t equals to 1.6 seconds, you substitute the value of delta V and delta T from the graph again, which is over here, into the equation, then you'll get this final answer. Okay, for number 2. A woman at an airport is towing her 20-kilogram suitcase at a constant speed by pulling on a strap at angle theta above the horizontal. So for A, this is the free body diagram. For on the y-axis, there's the weight, there's n from the surface, and there's also Fy acting on it. The forces on the x-axis, there is friction, and there's also Fx. So for B, to find the angle theta, first we use this equation because theta is towards the horizontal. Then we substitute theta with the forces that occur on the x-axis. And then you isolate for theta, and right after that, you inverse the cosine to get the angle. For C, to find the magnitude of the normal force that is exerted, note that the normal force occurs on the y-axis. So we start with the equation Fy equals to 0. And then we substitute Fy with all the forces that act on the y-axis. Then right after that, you substitute the value over here. Then you'll get that n equals to this. So we have the formula, the original formula, P equals to F per A. To get this formula, you can get that by substituting these values. So we know that F equals to MA, and A, which is the area. So in the end, you need to find ways to cancel A so that it will match up to this. You could do that by using other formulas like this. So I first start by using the rho equals to m per v formula. Then I turn it into this. I make m the subject. Then I expand v into cross-sectional area times height. So then I substitute m into this equation. Then I can cross out a and a. And for this A, we know that in this context, the A that we're using is the gravitational acceleration. So with that, we could get the equation that P equals to rho GH. For B, suggest why the equation in A does not give the total pressure of the base of the beaker. So in real life, the total pressure, if you want to find the total pressure, you also need to count for the atmospheric pressure that is available there. Because the total absolute pressure is also affected by the atmospheric pressure. So referring back to my previous answer, to determine the density, okay, so in this question, it mentions that the pressure that we're using is the total pressure. So we also need to take account for the atmospheric pressure. So we start from this equation. Then we expand this formula, and we notice that this is the gradient of this graph. So with that, we substitute m equals to delta y per delta x, which is delta pressure per delta x. Then we would get that our gradient is 7,500. And then we start from this equation again. Then we move g over here. Then we would get that our rho is equal to 760 kilogram per meter cubic. A salt cylinder is held stationary by a wire so that the base of the cylinder is level with the surface of the liquid. We are told to calculate for the new tension on the wire. So at first, the object, this bottom part of the cylinder, it is only touching the surface of the liquid. But in the end, the cylinder is lowered so that now the cylinder is fully submerged in water until here. So the forces that is acting on the free body diagram is the weight, the tension, and the upthrust. To calculate for tension, we start with the equation sigma Fy equals to 0. And then you would get that the tension is equals to 0.419 Newton. Sir, is that all?
Okay.
All right.
Okay, so for number 5, this question is basically just a block against a wall, and there is a force exerting into the block, and the block's mass itself is 3 kilograms, and the force is P, and the angle of the force pushing is 50 degrees. So this is basically the illustration of the yeah, so this figure is basically the illustration of the whole question, where the block's mass itself is 3 kilograms and the force is P, and this angle is 50 degrees. And the static friction between the block and the wall is 0.25. So for question A, we try to determine the possible values of the magnitude P. Okay, this is also an illustration of the questions. So the angle is 50. The angle is 50 degrees, and the force is going to the block itself. So these are the forces that will act on the block. So describe what happens. We just try to use the equation of sigma fx equals to 0 because it's on the x-axis, and it will become into px minus n equals to 0. So n will become px, and for the y-axis, the force that acts on the y-axis, so x sigma fy will become may, and py will become negative w, negative f. It will become to 0. And since this is a triangle, we can use the trigonometry. We use sine here because there is the opposite and the hypotenuse. So sine 50, as the angle is 50 degrees, we'll minus it by mg and minus it again by nms, and the result will become 0. So we just continue this equation. P sine 50 minus mg negative px ms 0, and then P sine 50 so we basically just input the values, and it will result in this equation, and then 0.609p will become 29.43, and we just divide, and we just find the value of p, and the p is 48.3. And then this is just when the block almost go up, and the next illustration is when the block almost go down. Okay, so when the block almost goes up meaning it's in the y-axis. So yeah, we find the y-axis first. Go down is also in the y-axis, so we also need to find the y-axis, but we also need to take into account the forces acting on going up and going down at the same time. So this is the illustration when the force almost go down. It's basically almost the same as going up, except with a few different forces acting, and we still use the same general formula and equation for this sigma fy, and will result in py plus fs minus w, and the final value will also be 0. The angle is also still the same, it's still 50 degrees, so we still use sine 50, and we also use the same equation as before. So sine 50 will be resulting to this, and we just input the forces into this, but the only difference with this is only the values of the forces. So it will become 0.93p equals to 29.43, and we find the value of p 31.6 newtons for going down. So the possible value of p will be, for going down and going up, the p will be at the middle of this both. So going down is 31.6, going up is 48.3, as we can see from the calculations above. So the p will be at between this or equals to this. So this is the final answer for A. Okay, so for B, the question is describe what happens if the force P has larger value, and what happens if it is smaller. Okay, so force P, they are referring to this force right here. So basically, if P is greater than 48.3 newtons, is basically the upward force. The block will slide up, because 48.3 is basically the benchmark of the force before the block will go up. And the P, if it's less than 31.6 newtons, the block will of course will slide down, because anything less than 31.6 is also like the benchmark for the block to go down. So yeah, this will be the answer for B. Yeah, that's it for this.
Static equilibrium. Try number 2.
Number 2, okay. Okay, so for the static equilibrium, number 2A, it's just stating the principle of moments. The principle of moments there is basically when an object reaches an equilibrium, the sum of the clockwise and anti-clockwise must be like equal to the object of the sum of. So basically, with the clockwise and anti-clockwise must be equal at the same point. That is basically the main definition of principle of moments. And for B, we are given this diagram, and the information is the load of weight 2.6 newtons is suspended from the beam at distance x from the pivot. So basically, the load is like hanging from the pivot, and a wooden cylinder of 4 newtons. So the weight of the cylinder here is 4 newtons. Is suspended also from the beam at the distance of 0.4 meters. So the distance from the pivot to the string of the wooden cylinder is 0.4 meters at the opposite side of the load, and the cylinder will rest in a container of water. The lower part of the cylinder is submerged to the water, so the depth is h, which is basically the depth cylinder of water h. And we're also given the information that h is equal to 0.1 meters and x is equal to 0.4 meters, and the system is in equilibrium. So the question asks us to use the principle of moments to show that the upthrust U exerted by the water on the cylinder is 1.4 newtons. So this question asks us to prove about the concept of principle of moments and equilibrium. Okay, so first thing first, we need to consider the cylinder as sigma f equals to 0. Use the same general equation, and then U plus T equals to W, and then we put the T by itself, so T will equals to W minus U, and then we're given that the W is 4, so 4 minus U. And then after we get this, the T equals to 4 minus U, we continue to the sigma torque equals to 0, and then we are given the value that this is 2.6 and it is times by 0.4. So basically 0.4 and 0.4, the x is 0.4 also. We just cross out the 0.4s, and the t is 4 equals to 4 minus u. So the equation will be 2.6 so equals to 4 minus u, and we try to put the u by itself, so u will equal to 4 negative 2.6, and the u will become 1.4 newtons, which is exactly the same as the questions 1 and 2. So for II, the density of water is 1 times 10 to the power of 3. Calculate the area of the circular cross-section of cylinder. Okay, so for the cross-section of the cylinder, we use this general formula of, and then basically we just try to input what we have the value. We already get the u, which is 1.4 newtons. So we just input the values above from the previous question. We just input 1.4 equals to 1000 times 9.8, which is the gravity. And then we need to find the area, and we already get the height of the 0.1, the h 0.1. So after we calculate this, basically just we get A equals to 1.4 times 10 to the power 3. Now for C, more water is gradually added to the container so that the depth H in figure 3.1, is this, gradually increases. The length X is continually adjusted so that the system remains in equilibrium. On the figure, sketch the variation of X with H and use the space below for working. Okay, so first thing first, we need to revert back again our attention to the previous diagram, which is this. And the question is asking us if more water is added to the container, the depth of H will increase. So the H will certainly increase. So first thing first, we need to revert back to the formula again. The sigma equals 0, and this also U plus C equals to W. And then we just continue on with the formula as we've done in the previous question. So it will become this, and T equals to this, as taken from the previous question also, this of the cross section. And since we already get the values for most of this, so we just substitute it in to find the value of T, the new T of this. So and then T will equals to this. It's still in the form of expression of H. So and then for the sigma torque equals to 0 is also the same. For the sigma torque, we already find is 2.6x equals to the T 0.8 negative x, and then 2.6x will equals to 4 minus 13.73h bracket 0.8 negative x also. And we just expand on this, it will become this. And once we already expand this, we try to separate the x-axis and the h. So in order to find the value of x, the value of x, and we just continue to separate it. It will become this, and then 6.6x minus 13.78x equals to 3.2 equals minus 10.98h. For this, since we are finding the value of x, the x we put it outside the brackets, and then 3. Is the same as above. So basically we've come to the conclusion that the x value will become this in the expression of h. So the question asks us to sketch the variation of x with h. So the x value is, we just input the x and h values into the sketch of the graph, and basically it will result in this red line over here. Yeah.
You do number 3.
Yeah. Okay, so for this question, given this arrangement, and you're given that this one is 4 kilograms, this one is 1 kilogram, and this one is 2 kilogram. The first task is to draw a free body diagram of each object. So for this one, you just draw what forces are acting on the object. So for M1, it's definitely the tension up here, and also the weight. And then for M2, this one is T1, which is the same as this tension, and also T2. And then aside from that, you also have the weight acting on it, the normal force, and also the friction, which is acting here because intuitively, because this one is larger than this, so the whole system is going to move this way. So friction is always opposing the motion, so friction is going that way. And then for the second one, we are using the law of F equals to ma. and then we're just substituting each variable with each object's forces. So for this one, F, for M1, the sigma F, or the sum of F, is the weight minus by the minus by the tension. Why is it this way? Because it's actually gonna go down. So you definitely know that the weight is larger than the tension. And then you just substitute this one, the mass is 4, and then this one is 4 times 9.81, the gravity, and then you get this equation. Now for M2, there's a lot more forces, but basically it's just T1 minus T2 minus Fk, because you know that it's moving there, so T1 is larger, and then the opposing forces for T1 is T2 and Fk, which is the force of friction. And then the mass is 1, and then you get the second equation. And for the third equation, for M3, it's the same as M1, but this one, the tension is larger than the weight, so it's T2 minus M3G, and then you substitute, and then you get the third equation. And then to find the acceleration, you just need to do simultaneous. You have 3 equations, and then for this one I used substitution by substitution. So you substitute T1 with this one and substitute T2 with this one, and then you get the A is 2.31 after you solve it and then simplify it. And then for C, you're asked to find the tension. Since you already know the acceleration, so you just need to substitute it into these equations. So for T1, the tension is 30 newtons, and then for T2, the tension is 24.2 newtons. And then for D, there's given a condition that the tabletop is smooth, so basically less friction. So for question D, there's 2 methods actually. You can do it intuitively, or you can just see the equation. Intuitively, you know that basically when an object is falling faster, it means that the opposing forces or the resultant force is larger. So it's either that the force pulling it down is larger, or the forces pulling it up is smaller. So when the acceleration increases for M1, the T1 decreases because T1 is the force opposing, and then for the T2, it's increased because it's going up faster, so the tension is going to be higher. But you can also see the equation. So basically when this value, the A, is increased, this value is going to decrease. And then for T2, when the acceleration is increased, this value is going to increase. So yeah, this is how I arrived at the conclusion. Static equilibrium, sir.
Yeah. At the equilibrium, number 3.
Yeah. Okay, so for number 3, it's asked for the definition of center of gravity. So center of gravity is a point where the weight of the object acts on it. And then for question B, given this arrangement, okay, okay, so all the information is given in the graph. So by taking moments about the pivot, calculate the tension T in the string. So we know that the beam is in equilibrium, meaning that the moments clockwise is equals to the moments anti-clockwise. Now for the moments clockwise, the ones that are the forces that are producing the clockwise moments is this one, 2.4 newtons, and the vertical component of the tension T, Ty. Okay, and for the anti-clockwise, it's this one, 54 newtons. So by equating those two, we're actually gonna get the Ty. So as you can see here, the anticlockwise moment, 0.45 meters times 54 newtons, is equal to all of this here, which is 0.95 times 2.4, and then 0.95 plus 0.35, which is the whole entire length of this, where the vertical component of t is acting. And then you just solve for ty, and then you get this value. Okay, now for finding the value of t, you're gonna have to use trigonometry. So this one is the diagram. So the vertical one is 16.9 newtons, and you're given that the theta here is 60 degrees. Why? Because this one is 30 degrees, this one is perpendicular, so this one is a complement angle, 60 degrees. Okay, and then you just use cos, because you know the adjacent and you know the hypotenuse. So cos theta equals to adjacent over hypotenuse, and then you solve for t, you get 34 newtons. Okay, now given the condition that the string is cut so that the beam is no longer in equilibrium, so basically this question says that it's the same system, same arrangement, but assume that the string is non-existent. So you only have these two moments right here. So you just need to calculate the resultant moment, which is 54 times 0.45 minus 0.95 times 2.4. So this moment minus this moment. Yeah, okay, that's it.
I start, sir? I start? Okay. So for this question, the first one is there's constant current in this solenoid, and it's asking for the variation of magnetic flux linkage in coil C from X to Y. And because X to Y is not moving out of the solenoid, then it doesn't create any magnetic flux cut. That's why the flux linkage is constant and straight. And that's basically for the explanation in II. Explaining the shape of my line is because inside the solenoid it is said that the current is constant, and then the magnetic field is also constant, and then so the N, since it's also constant, there's no change in magnetic flux linkage. That's why it's directly proportional to this formula. Okay, for the next one, it's asking for the maximum magnetic flux linkage, and this is the graph we have, and the maximum magnetic flux density is 0.08, and then the area was given before, which was 0.71 centimeters square, which is why we made it 2 meters, and then the N is 64. So we calculate, and then that's the result. And then for the next one, the EMF, it's the gradient of magnetic flux density, the negative gradient. So if the magnetic flux density has constant gradient, then EMF is 0. And then since magnetic flux density is positive, so it is in the negative area. And then for the one from 2t until 4t, since it has a negative gradient, so it becomes positive. For the calculation, we use the normal formula, which is the gradient of the B. So for t until 2t, it's 0.08 until 0.04, and then 2t minus t. since the N and A is constant, so we don't need to calculate for that. And then the same thing for 2t until 4t. And then last one, why it's asking for the change in distance between the turns of the spring. So because current is flown from the DC power supply to the spring, it has current flowing in the same direction within all these springs. So because it all has the same direction, they exert a magnetic flux density between them, and because the magnetic flux density overlaps with each other, it creates a force which is attractive to each other. So this makes the distance of the spring closer to one another. For the next one, it is quantum physics. Explain with reference to the photons why there is a single frequency of electromagnetic radiation that corresponds to each of these transitions. So in the question, it was given the 4 energy levels, and we can tell that it's discrete, like it has no in between. And because of this, the electron falls only from one level to another, and each energy level is specific to a frequency, and which is equal, so like the photon energy is equal to the energy difference that the electron travels. And because of this, the energy is fixed. Next one. Draw a line that corresponds to the transition of the electron from N2 to N1. So since the relationship of frequency and energy is directly proportional, so from N2 to N1, it has the smallest energy. So the frequency drawn in figure 8.2 is lower. If we take reference from the question, it says that the one from N3 to N1 is this one, and it has quite a big energy gap, and then the one with N4 to N1 has a bigger energy gap than that one, so it has a higher position. And since 2 to 1 is smaller gap, then it has a more lower position. And then the one from 3 to 2 has a much more smaller gap, so explaining why it has a much lower position than the other 3. So for this one, it's asking to find the formula of E3 in terms of FA, FB, and E1. And we are given that FA is the frequency of the line A, FB is the one from B, and E1 is the energy from the ground state. So we find the E3 by finding the difference in energy. So for E2, for the FA, it goes from the energy level N2 to N1. That's why this is like this. And then the FA is the frequency of this one. And then for the other one, we can do from E3 to E2, which is FB. And then from here, we can just do elimination. We remove the E2, which makes it E1 minus E3. And then so we can find the E3, which is this one plus E1. Next is the definition of binding energy. It's just the definition by book. Okay, so it's the total energy needed to completely separate all the nucleons in the nucleus divided by the number of nucleons. Oh, okay, my answer here is wrong because it's not binding energy per nucleon, so it's just the energy needed to separate into infinity. Next, mass defect. It is the difference with the mass of the proton and neutron minus the mass of the nucleus. So we're given the mass in the table, but it's still in U, so we just change it to kilograms after we calculate at the end, which is here. And yes. Next, the binding energy. We have the formula mc squared. So we use the mass defect from the one in I, and then we multiply it with the speed of light, which is 3 times 10 to the power of 8 squared, and we have the answer. And then the binding energy per nucleon is just dividing it by the number of nucleon, which is 212. This is the graph that we have learned. It's the binding energy per nucleon against activity. And we are asked to sketch the variation from 1 to 250, and the peak is at 56, which is, I forgot what atom it is, but it has the highest peak right here, and then it goes, the gradient decreases over time. And then we're asked to draw an X which shows the position of polonium-212. So it's just around here since it's 250. And then explain why the alpha decay of polonium results in the release of energy. So this is because for alpha decay, it's usually experiencing fission. So if we want to see it from the graph, it goes from the right here until here. So why it releases energy is because the nucleus formed it has like a smaller nucleon number, and it also has a higher binding energy per nucleon, which is why the final atom will have more energy than the one before, resulting to the release of energy. That's it right there.